So welcome everyone to Bristech Bytesize number 15. Good to see you all. And if you haven't been to Bristech before, then this is a slightly modified format from the in-person because it's online. Bristech started it as a meetup back in 2013, and since then we've grown to over like 3,000 people in the network. We had the first conference in 2015, and last year we had an ML Ops event that went down really well. But this year, for obvious reasons, we've been biding our time in terms of what offerings we've been putting out there and what events we've been organizing. So we'll see what the end of the year next year brings. But tonight, I'm really pleased to welcome Antoni Baum. And Antoni's going to be talking about PyCaret, which might be a Python library that isn't particularly well known. I guess that's why I was so interested in it, to see what the angle of PyCaret is in quite a crowded marketplace. So Antoni will be giving a presentation, and then we'll be joined by Taha, who's going to be part of the panel discussing some of the wider issues arising from the talk, which is really excited to have Taha here too. Hi. So the rough timings, the talk's going to be about 15 minutes. We will have Q&A, which is then curated via the chat window. So if you do have any questions during the talk, then they'll be saved until afterwards, and then I'll ask people to unmute and ask their questions. The default is muted. But it would be good after the talk, maybe if we show our appreciation and unmute at that point. So after the Q&A, we'll then go into a bit of a panel discussion, and we'll probably keep it to about 45 minutes, pretty punchy. If we run over, we do apologize. Let's see where the conversation goes. So excited to see what their themes are arising from the talk. So a few little housekeepings. Please do introduce yourself on chat. We're very interested in the audience and what your background is and your interest in this particular topic. So that'd be really useful. And if you do want to turn your cameras on, that's brilliant. It's obviously always good for the speakers to have faces, but we'll leave it for you to decide. Default is muted. As I said, if you want to unmute, then please do show your appreciation from the talk and ask any questions. So I am thrilled to have Antoni here tonight, who is one of the PyCaret maintainers. So we're hearing it straight from the horse's mouth. And so over to you, Antoni. Please do take it away.
Hello, everyone. Pleasure to be here. So as Nick has said, the topic of my talk is machine learning made simple with PyCaret. So the agenda for the talk is first, I will introduce myself, then talk a little about the machine learning lifecycle, then about the PyCaret itself, and how it can empower citizen data scientists. We'll wrap up the talk with a short demo. So a little about me. I'm a computer science and econometrics master student. Right now I am in the middle of my degree. I am a software intern at Anyscale Incorporated. And perhaps most importantly for this talk, I am a PyCaret core contributor and maintainer, and have been so for almost a year. The important links are just listed here. You will, of course, have access to the slides afterwards, but if you want to take a screenshot, feel free to. So when we think about a machine learning lifecycle, it can be divided into several stages. Furthermore, when we get to the deployment and monitoring phase, it is often necessary to update the model by sourcing new data and running through the steps again. PyCaret focuses on two of the steps of the lifecycle. That is the data preparation stage and the model training and selection stage. If we were to take a closer look, we can see that it can be quite a complex process, with data having to be split into train and test sets. Missing values have to be imputed, features called, categorical features have to be encoded, and further feature engineering has to be done. Finally, we need to select a model, we need to train it, we need to tune its hyperparameters and optionally create an ensemble of models. After we are happy with our results, we need to verify them again on the test set, and then finalize our pipeline and deploy it and monitor it. PyCaret helps you to do all of that, which can be, as I said, a tricky process which can be easy to get wrong, especially if you're a beginner or lack expert knowledge in data science. So what is PyCaret? PyCaret is an open source, low-code machine learning library and end-to-end model management used to automate machine learning workflows. It is commonly used for rapid prototyping and deployment of machine learning pipelines. PyCaret is written in Python and is completely open source and non-commercial. We tried our best to make it easy to use with our functional API, especially for newcomers to data science and people who might not have chance to write code in Python before. We made it a productivity tool, cutting as much boilerplate code as possible, ensuring that you as a data scientist can focus on the bigger picture, and it is business ready. In fact, we know that several businesses are already using PyCaret in their day-to-day. What PyCaret brings to the table is automated data preparation, which is done according to the best practices while still allowing the user to choose more advanced options. Model training. With our compare model functions, you can effortlessly run over a dozen models on your data and choose the ones that give the best metrics. Automated hyperparameter tuning with several options available, from grid search, random search, and various types of Bayesian search, which often gives better results than simple random search. We provide analysis and interpretability tools such as plots, SHAP values, and other ways to interpret your models. Automated model selection, which lets you create a simple AutoML solution using PyCaret. And finally, all of the steps in the experiment are logged, which allows you to easily recreate it. The machine learning use cases that PyCaret supports are as follows. For supervised, we have both classification and regression, and recently we have released an alpha of the upcoming time series module. For unsupervised, we have modules for clustering, anomaly detection, association rule mining, and natural language processing. All modules have a similar API and can be used interchangeably or in a chained way. When we look at the statistics of PyCaret, we can see that it has over 500,000 downloads, over 3,000 GitHub stars, over 46 contributors, and today we have over 2,000 commits. This value we have here is a bit out of date. We have multiple contributors as an open source project with a core team of maintainers that sets overall goals and provides code reviews as well as major features. But we also encourage everyone to contribute to PyCaret, as even small changes can be very meaningful. PyCaret doesn't reinvent the wheel. Instead, it wraps around popular Python machine learning libraries while removing the need to know their APIs. We provide wrappers for scikit-learn, Rapids, MLflow, XGBoost, LightGBM, CatBoost, Optuna, Yellowbrick, Plotly, and many more. Another advantage of this approach is that all of the pipelines and models created with PyCaret are fully compatible with the rest of the Python ML ecosystem. Furthermore, we provide an option to train your models on a GPU using Rapids, as well as the option to do your hyperparameter tuning in a scalable way through Ray. And this is all done through PyCaret itself without the need for any setup or extra code. So there is a growing trend where people who may not possess an expert knowledge in data science are nonetheless taking up the work that has been traditionally done by expert data scientists. Gartner has defined those people as citizen data scientists, and in short, those are people with domain knowledge about the data who do not possess necessary practical skills to create their own ML solution from scratch. As of 2020, there were 3 times more data science job postings than job searches. This means that citizen data scientists are going to fill in the role of professional data scientists just because of the skills shortage. Data science talent is expensive, and the average data science salary is over $1,001,000. However, analytics tools are easier to use now, which reduces the reliance on data scientists, thus enabling people who might not have professional training or academic knowledge about data science to nonetheless create machine learning solutions. However, there are many challenges for such people. Machine learning is an iterative process, and it can be very time-consuming. And the right tooling in the hands of right people is very important, and that tooling needs to match their skills. Creating seamless pipelines is hard, and managing it in production is even harder. And focusing on the end goal and the bigger picture can take a backseat with small teams if the technical depth is increasing. And how can PyCaret help with those challenges? First of all, its API is extremely simple and quick to learn. It reduces the need for boilerplate code massively, allowing even people who did not have much experience with Python to quickly create an experiment. All of the models created with PyCaret can be interpreted and explained using built-in features, which allows the human to be constantly in the loop, as well as all of the steps to be logged for easier, finally, the pipelines that are generated not only use best practices under the hood, which may not be known to newcomers to data science, but they are also compatible with Python machine learning ecosystem and can be rapidly deployed to production. And it integrates with multiple libraries without requiring the knowledge to use them. So who and why should use PyCaret? First of all, citizen data scientists, as well as beginners to data science, can use PyCaret to create explainable pipelines according to best practices without the need for expert practical knowledge, which can be quite hard to obtain considering the scope of the Python machine learning ecosystem. Businesses and academia can quickly add value from machine learning without the need for expensive tools and expert knowledge. PyCaret is not only easy to use, but also completely free and open source. And finally, even professional data scientists can use PyCaret to do rapid prototyping, as well as a jump board for more advanced projects, because all of the models created with PyCaret are compatible with the rest of the ecosystem. So I would like to quickly show a demo of a regression problem on insurance data. So let me quickly switch to the right window. So as PyCaret is a Python library, it is completely optimized to be run in a Jupyter notebook. After installing PyCaret, we provide a way to quickly obtain example data sets. Here we'll be using the insurance data set. The PyCaret setup function takes care of all the data preprocessing and is highly customizable. For more details, I implore you to check out PyCaret documentation. Here we just run setup on the insurance data, setting the target column as charges, as well as session ID to 1 to 3, which allows us to set the random seed to that value. The setup function prints a table summarizing the steps it has taken. We can check how the setup function has transformed our data by using getConfig on xtrain. As we can see, the categorical features have been one-hot encoded. Then we can run the compare models function, which runs cross-validation on the training data on all of the models in the PyCaret library, summarizing their performance in one table. We can see that the gradient boosting regressor from scikit-learn has obtained the best R2 score. We can also create an individual model, which will give us a more detailed per-fold performance data. Here we create a decision tree model. Then we can use our tune model function to optimize the hyperparameters of that model. We chose Optuna as our optimization backend, as well as 20 iterations of optimization. We can see that the R2 score after hyperparameter optimization has increased considerably. We can also ensemble the model through bugging using our ensemble model function, as well as create a voting ensemble of various models using blend models, or a stacking ensemble using stack models. We can evaluate the model through an interactive dashboard created with evaluate model function, and interpret it through SHAP with interpret model. Finally, we can obtain predictions on either test data, which has been automatically separated during setup, or on unseen data. When we are happy with our model, we can choose to finalize it, which will train it on all available data, save it to a file, and finally deploy it on Amazon, Google Cloud, or Azure. This is an end-to-end Python machine learning workflow done completely inside PyCaret. So that will conclude my talk. If there are any questions, I am happy to answer them.
So thanks, Antoni. Let's, if everybody could unmute, and let's thank Antoni for his talk. Thank you.
Thank you.
So are there any pressing questions? If you've got any initial questions, please do post them in the chat. We had one from Taha.
Mm-hmm.
Would you like to, Taha, do you want to unmute and ask that question?
Yeah, sure. Hi, everyone. I just want to know more about if you need like find machine learning, developed machine learning off the shelf, and we need to use PyCaret with a developed one. Could we like customize it with a platform, with a local platform?
So it is possible for users to add their own models to the PyCaret model library, provided they use a scikit-learn compatible API. We are also considering developing new modules to cover more machine learning use cases. As I said, the time series module has just been released in alpha, and we are considering a deep learning module. Furthermore, from our side, we sometimes add new models to the library. However, we try to keep it contained to the most common models, as of course, adding all of the possible models to the library would be a great undertaking that may not be as helpful as one may think.
Yeah, I have a second question regarding with the data preparation. Do you have PyCaret the vision to like add more facilities tools for near future for data preparation? Or yeah, it's like
data preprocessing is one of the areas that we are currently improving. We are going to move to a more customizable and robust API which will allow the user to completely customize the pipeline using both built-in steps as well their own custom steps. That being said, PyCaret has been built with tabular data in mind, and we did not consider other types of data just yet.
Yeah, thank you.
I have a question. Oh, we're gonna have a question here. Adam, do you want to unmute yourself? Go for it.
Thank you. No, it was just a quick question. You mentioned that it was PyCaret was optimized to run in notebooks. Can I just, would it be possible just to, access it from a normal sort of IDE? Is that a really bad idea? And it's like, don't
no,
do that.
no, of course not. So PyCaret is optimized for notebooks, as I said. However, you can just run it perfectly fine as a normal Python script by turning off the notebook support, for the plots and so on. But it can be run as a normal Python script. And I know a few users that have used PyCaret to create simple machine learning apps, web apps.
Yeah, that's basically, that's what I was asking. Thank you.
Great. So if there aren't any more questions, we might just vamp straight on. And perhaps Taha, you would like to just introduce yourself, and then maybe we can go into some questions for the both of you.
Yeah, sure. My name is Taha. I'm a machine learning at For Earth Intelligence. My main role involved with using remote sensing, AI solutions, and with geoscience.
Great.
With a computer vision.
And for people who don't know what remote sensing is, do you just want to sort of
yeah,
say
I can just remote sensing any technology related with using satellite imagery or drone data for different applications scenario to help to make a reliable decision with applied artificial intelligence.
So perhaps a little bit of a leading question for you then, Taha. Based on what you've seen from Antoni's presentation, do you think that PyCaret is going to be able to eke out a position for itself in the life cycle?
Yeah, sure. Maybe in near future, we are currently solving some solutions related with the machine learning by using applied deep learning solutions. Some of them need we need to use traditional machine learning. However, some challenging we are facing currently of applying artificial intelligence with the remote sensing is to fill the gap of pre-processing steps in order to make it compatible with a standard model training. So what I mean, currently we use a customized model in order to fill the gap between remote sensing capability with the machine learning to make it a reliable solution.
So do you see there PyCaret could fit as a data preparation for deep learning? Is that how you would see a tool like this within your organization?
I can expect it in the near future to fill the need for deep learning using low code open source platform. Currently, most of the limited data set with the cost it's need to train it with using either using data augmentation, further processing in order to fill and enlarge the data set and make it the training more with a higher quality. So what we hope from the low code open source is to fill the requirements for pre-processing for deep learning tools. I'm sure it is a bit tricky at this stage, but we expect in near future maybe we'll find more solution from the open source low code platform to fill the gap currently we faced from about preparation, data preparation, and data synthetic data training at the moment which face.
Okay, that makes really good sense. So, Antoni, do you want to respond to that from a point of view of PyCaret seems to be focused, or one of its focuses is on the data preparation step. So is that what you see the niche here for the library?
Definitely, data preparation is one of the harder steps in a machine learning lifecycle, as there are many things to consider. For example, some types of data preparation may not work well with a given model, or some types of data preparation may in fact give worse results than others. Therefore, having a way for a data scientist, especially a beginner or a citizen data scientist, to do data preparation according to best practices without having to really know all the nitty-gritty of it, is something that PyCaret and other libraries are striving towards. That being said, the issue right now is that PyCaret and many other libraries are focused on tabular data, which is still the main type of data, especially in business setting. But there is definitely a niche for open source tools for data preparation of vision data, of sound data, and the like.
But there's still a gap there, is there, in terms of the actual nature of the data? That was the sort of the point that you were alluding to, wasn't it, Taha?
Yes.
Yeah, adding to Antoni's point, because we are living with very fast advance, like racing with the manufacturing with different data registration sensors, and this point is important. Why? Because the nature of the data source for training is very varying with time, so it's need to cope the gap between data feature extraction process with a standardized feature extraction from different data sources. So what I mean, if you take, for example, my experience with dealing with the remote sensing, we will face a huge of variations of different data sources. These data sources generate a customized data set. So how to deal with the different data sets? This is the big question for the near future. How to cope the available open source platform for machine learning with the huge varieties of limited data sets, and at the same time with different types of data sets. How to make it to make the standardized pre-process to fill all the requirements. This is also it's need in my mind in near future. It still will continue with the feature extraction engineering. It is high demands nowadays. Now implementation for deep learning, it's easy. Machine learning easy because of the availability of open source low code platforms. But now the bottleneck, how to use correctly and an efficient way using feature extraction from the limited amount of different types of data sources.
Okay. And how much do you feel that the experimentation and the sort of the rapid prototyping, presumably that goes pretty well with the low code, because you're just wanting to conduct experiments really quickly, and you're not necessarily expecting them to get into any kind of deployment?
This is a question for me.
Oh, either of you. I don't mind.
For myself,
perhaps you want to speak to that one?
for myself, it's okay. It's easy.
Go ahead, Taha.
Yeah, for myself, it's easy because of availability of different open source platform, and the coding issues is less than before. Like if I compare it with previous 10 years or 5 years. It's a huge of improvement with this.
So the tooling it's been improving and improving over time.
And everyone can use train and deploy machine learning. But the question is the pre-processing, how to manage, prepare the data. Are these steps for these steps to follow?
And Antoni, anything to add to that?
Oh, Jennifer.
Sorry. Okay. So.
Hello. Sorry. Who's that jumping in? Jagan, were you trying to jump in there?
No. Sorry. Apologies.
Okay. No worries. Antoni, do you want to just so we were talking about rapid prototyping, sort of low code. Yeah, do you want to pick up on that point, or should we move
right
on?
So just a quick note from me. The issue right now with all of the different libraries composing the Python machine learning ecosystem is that many of them have widely differing APIs, and many of them require a considerable amount of boilerplate code to be written in order to conduct an experiment. So a low-code solution like PyCaret, where you can do with just a few functions what would normally require a considerably larger amount of code, is certainly a good way to rapidly conduct an experiment, and then it is possible to just further customize it and improve it, perhaps outside of a low-code solution.
Okay, understood. And therefore, I can see how it ties into the citizen data science as well, because low barrier to entry, and therefore people can get going. I was wondering, is the sort of elephant in the room here actual access to data? It feels that the actual tooling is all open source. A lot of the other, TensorFlow, scikit-learn, they're all open source, but not necessarily open source data. Do you see that as a bit of a barrier?
I think that yes, definitely. Like a good chunk of a good model is comes from good data, and if we don't have access to good data, it is hard to do any sort of meaningful machine learning. Many businesses, especially the larger ones, have their own private sources of good quality data, but smaller businesses as well as the academia and hobbyists struggle with obtaining data that is not only of good quality, but which is also representative of the problem they're trying to solve. While we have some open source repositories of data, they of course don't contain every possible business case for data. So seeing some sort of a push from especially some of the larger companies like Uber, like Microsoft, to share their data and democratize data science more would be a great thing to see. But seeing as data is one of the most valuable resources a company can possess, I can't really see them sharing that freely.
Yeah, there's a bit of a tension there. I don't necessarily want to get into the sort of the business side of it, but there's a tension between data that's freely accessible and data that's not. I'm just wondering whether businesses could harness or in fact release some data for citizen science to be the long tail of what they're doing. Is that a trend in business? Are you aware of businesses who are going down that road?
I know of businesses who make it possible for citizen data scientists to actually make a living. That the business model is that small businesses which may not have their own data science team instead outsource it through that platform to citizen data scientists. That being said, I am not aware of any companies sharing large and meaningful amounts of data.
Yeah. So how would for Earth Intelligence, would that something that your particular business would take on, or do you think that's a bit of a long shot?
Yeah, it's because we are dealing with the different providers. So some datasets is access is openly available, and some of them we are very dealing with to provide very high resolutions datasets. Some of them they provide with a limited access just for testing. Some it's depends on the providers.
Okay.
There are some restrictions of using the datasets with the privacy, some rule we need to follow how to use the data.
But presumably there's also lots of public data sets. Like, for example, like you've got Sentinel-2, haven't you, for satellite imagery? Presumably you pull quite heavily on public data sets from satellite, European satellite projects.
That's correct. But everything there is a trade-off. There is no perfect with the openly available data set. So you need to use another important subject with the data fusion in order to get more high quality data set for training, to get more reliable machine learning model.
So could you explain that data fusion? What does that mean?
We usually, in order to train, for example, object detector or classifier with a more reliable performance, we need to train the model with high quality training data set. Unfortunately, some of data sets, it's like for some of for example, we need to improve the resolution on customized data set. We need to fuse two data sets in order to upsampling the data sets and make at the end improve the training quality, because it's the successful of machine learning training depends on one of the main parts on the training quality, depends on the dataset quality. So the main idea there is a several stage we ensemble them in order to get the good results at the end. Especially we are dealing with a customized dataset. So, and also machine learning is not it's need to be optimized with the available dataset. I mean, talking about visual contents datasets. It's need minimum requirements we need to meet in order to get a successful implementation.
So you have quality parameters that need to be met before and that's
exactly.
where data fusion steps in.
This is one.
Just changing tack slightly, coming back to the second tenet of PyCaret, which is to do with model selection. I'm just wondering, in terms of the limits to AutoML, and then sort of comparing the traditional ML and Python to AutoML. Antoni, is that something you would like to speak to?
Right. So basically, we are seeing that there are more and more high-quality AutoML libraries, and even libraries like PyCaret, which are not necessarily built towards full AutoML, do have some AutoML functionality. And if you look at the academic papers and rankings, we can see that AutoML solutions have been steadily growing in performance and sometimes even outmatching seasoned data scientists. That being said, the main issue with AutoML tools is that first, the optimization loop takes a long time to try various combinations of model and preprocessing and hyperparameters, which is sometimes a knowledge that a data scientist may possess right away. And perhaps the more pressing issue is that AutoML solutions behave like black boxes. While there is some limited interpretability tooling, which is not always the case with all solutions, the whole process of model selection and pre-processing step selection and tuning is not necessarily clear, which may be an issue, especially in some industries like finance or healthcare. That being said, I can definitely see AutoML solutions being used more and more, especially by businesses that cannot afford a full data science team. And I can definitely see AutoML solutions and other low-code solutions like PyCaret augmenting data scientists with their own experiments.
So augmenting but not replacing.
Yes, yes, precisely. I don't think that's going to happen for quite a while.
Yeah, but I guess that the place for AutoML is perhaps in getting going quickly. Is it actually in the rapid prototyping?
So I would rather say this is more of a domain of low-code tools like PyCaret. AutoML tools allow you to pretty much get the best model quality if you give them enough time. But the very nature of how optimization works and trying out different combinations requires a good deal of time and/or processing power.
Okay. And Taha, it's presumably in what you do, because you're using very sort of specialist models, kind of AutoML is just not an option.
Yeah. Yeah. Currently, we're focusing with trying to optimize the over-the-shelf machine learning, more specifically with the deep learning models, to make it more suitable and suitable for remote sensing applications.
Mm-hmm.
So this requires a lot of efforts with the feature extraction, preparation for training data set, and also one important point, how to deal with limited data set. There are many, several research ongoing to reduce this issue. One of them is we are using synthetic training, and synthetic training is focusing on how to generate more instances based on the target objects or target user case. So in this case, it's need computer vision work preparation in order to simulate the training samples, speaking with the visual contents datasets. Also, with the data augmentation, it's need to be more flexible and more targeted with what we going to use. If we are using for mainly with the vehicle detection, we need to augment the samples of training to simulate the targeted small objects.
And would you say that that's more research of a research topic?
Yeah, it's applied research and at the same time. Yeah.
Because one question here is to whom PyCaret is actually aimed at, and presumably it's aimed at more machine learning engineers than data scientists. Am I right in that sort of assertion?
Sorry, Antoni can answer this question.
So we have made PyCaret for people that may not possess the necessary practical skills that are associated with machine learning. And the practical skills are mostly the domain of machine learning engineering. Instead, what we want to do is to allow people who possess the necessary theoretical knowledge, which is data scientists or citizen data scientists with domain knowledge, to easily create the workflows. So I would rather say that PyCaret is mainly targeted towards data scientists than the more software engineering side of machine learning. But of course, the models created with PyCaret can be easily deployed and put into production, and which is at the point where machine learning engineers take over.
I see. Okay. Yeah. So actually, it's the other way around. it's data scientists who want to who don't necessarily want to do too much coding to actually get
precisely
production. Yeah. Okay. Okay. Gotcha. And do you see, and this is to both of you, do you see a bit of a tension here between these roles and the overlap? You know, researchers as engineers or engineers as researchers. There's still a bit of a gray area.
Yeah, speaking about myself, because of now availability of open source low code solutions, it's need like the requirements with the machine learning. As a machine learning engineer, it's need to cover both, keep updated with the state of the art related research, conducted research, at the same time trying to apply and optimize or develop or design the algorithms, require algorithms in order to fit with what I'm doing for use case, applying the AI solution. So it's look like a complement, machine learning tools with the research at the same time. So make a time management between both of them, how to use the tools and keep updated with the latest platform and libraries, and at the same time keeping my eye with the latest technology and research, conducted research.
Sounds like two kind of like overlapping, yet quite far apart. There's quite a lot to have to get a handle on and keep yourself on top of in terms of actually fulfilling the role.
And yeah, the most challenge also I think with implementation, trying to whenever have idea need to implement a prototype and test it, is need be familiar with the code and the libraries and like trying to solving any issues related with the conflict of libraries. And this is maybe it's help with the low code open source solutions, make the life more easier for us.
So we have actually run out of time. We've burned the time. It's been a great conversation. I was just wondering whether any sort of final thoughts or observations or questions from you, Antoni, and indeed from you, Taha, on any of the themes that we've been exploring.
So from me, I think like there is definitely a trend towards greater standardization and making machine learning easier in the practical sense, which I think is going to save a lot of time and enable more and more people and businesses to take advantage of machine learning without requiring expert knowledge and requiring their data scientists to have both knowledge about the data science itself as well as how to implement it. But as we have noticed before, the next great frontier for open source, which perhaps will require different approaches, is the data itself.
Yeah. Taha,
anything? Yeah. Adding to, I agree with what Antoni said. Adding to that, the data itself. This is like an oil that fuel the machine learning or AI solutions. So I expect like in near future, we'll see data preparation process open source platform. So everyone can have a solution using the availability of how to use generate data training solutions.
Okay. Well, Antoni, Taha, thank you so much for sharing all your nuggets of wisdom tonight. That's been incredibly useful. We will actually be posting this up on our YouTube channel, and for all of our previous videos, please do check out briz.tech/videos. There's content from, I think, almost every single meetup we've ever done. So there's quite a bit of stuff going back there, and the MLOps conference from September is on there as well. The next event is going to be the first Thursday in August. So if you've enjoyed tonight, please do come along. We will be announcing on Twitter who the next speaker is going to be. And our sponsors for this year, obviously, they make it happen. They are Ovo Energy, Storm, Oracle Cloud Infrastructure, and GoCo Group, who actually have been support by future publishing. So I need to update the slides with future on it. So thanks very much for listening, and hopefully see you again sometime. Bye.
Thanks, guys.
Thank
It's
you.
been great.
Bye-bye.